This problem is about normality. So the test we're going to use is the Shapiro-Wilk test. Remember, this is slightly different in the sense that if our statistics is greater than the critical value, we do not reject. Okay, how do we do this test? The first thing we need to do is to compute there are two numbers to compute it, which you can see in the formula set. One of them is the sum of all the data minus the mean square, for which we have to compute, of course, the mean. The mean will be just adding all the points, 1.25 plus 1.31 plus up to 1.15 divided by the number of points, which in this case is 9. So that's equals to 12.77 divided by 9 equal 1.42 to compute this number here. So we just simply add this difference squared. For example, 1.25 minus 1.42 squared plus 1.31 minus 1.42 squared plus all of them up to 1.15 minus 1.42 squared. And I got here, in my case calculator, 0.3279. Okay, now we have to do and compute a little bit more some multiplications, as I explained in class. For that, we have to order the numbers in increasing order. So our numbers are xi equals to the smallest of numbers, 1.15, increasing order, right? 1.25, 1.26, 31, 37, 51, 53, 1.61, 1.78. And now what we do? We take the biggest, this one, minus the smallest, so that's 1.78 minus 1.15. And multiply by some coefficient here. We look at the coefficients now. Plus the second one, 1.61 minus 1.25, 61, sorry, here, minus 1.25 by another number, plus 1.53 minus 1.26 by some coefficient, plus this one, 51 and 131, plus some coefficient, I'll tell you now where it comes from 1.51 minus 1.37. Okay, and this one, because it's odd and it's left, so this we don't do anything. This one, you forget it. If you were even, instead of 9 points, we had 8 points, there will be nothing to forget. So how do we get these numbers? We get it from a table that I will show you next. So we come to the table where we have the coefficients, 9 data points. So this is the column we have to look at, and B will be the first coefficient, 0.5888, times whatever the difference we had computed. We have only written before, 178, the biggest minus the smallest, plus 0.3244, and then the second biggest minus the second smallest. And we'll continue like that, plus 0.1976, and the next one are 1.53 minus 1.26, plus finally 0.0947 times 1.51 minus 1.31. Remember, we have one extra point there that we don't do anything with it. We do this in the calculator and we get is 0.56002. I'm using several decimals because I have the calculator, so it doesn't matter. Now the statistic we get has to be computed as b squared divided by the sum we did before. So that will be 0.56002, the whole number squared, divided by 0.3279. And I get 0.9564575. Don't need to compute so many decimals. And now let's look for the critical point in the table. So we have a significant levels of 5% here and 9 points. So our critical point is 0.829. statistic we have computed, it was 0.956, which is greater than our critical points, 0.829. So this is the case where the things go reverse. In this case, we do not reject the null hypothesis. So this means there is not enough evidence to reject the fact, we do not reject the fact that the sample comes from a normal distribution. There is not enough evidence to do that. You would have to check more, but you cannot say that it's not coming from a normal distribution.